There's lots of you today. Welcome to the IPFS Filecoin technical Q&A with Jenks. This is Jenks. He's going to talk for 10 minutes, going through a couple of his slides. Then there'll be some time for you to ask questions and have to give answers to. And then after that, if there's still time, he will show some of the software that he has developed. Jenks, I will hand over to you.
Thank you, Alex. Hi, everyone. Glad to see so many names on Zoom. 142 participants. This is great. So today I'm Jenks. I'm developer advocate at Filecoin Foundation. We work closely with Protocol Labs to advance the agenda of Web3. So for today, I'd like to give you a little bit of update on the network statistics, talk a little bit about Web2's challenge and why Web3 and IPFS system specifically. It's a little bit different than the talk that I've given before, introduction to IPFS and Filecoin. And then I'll just open up the floor for hackers to ask me questions. It could be anything. And please do feel free to ask questions. You don't have to wait for it as well. You can put it in the chat and we'll go through that after one by one. I can even show you a little bit of the coding that I have done for demo softwares to demonstrate how you can use Filecoin IPFS in your project, how easy it is to use it and be eligible for Filecoin hacker track. I can also demonstrate how to use NFT storage and Web3.storage and S3.tech, a few technology that I mentioned earlier in this AMA. So I hope you're going to get lots of value out of this. So I'll share my screen now. It is just my browser tab. I brought up a public meeting slide out. In our ecosystem, many of our public meetings are actually, as the name suggests, it is public. So we actually get lots of teams together and ecosystem partners or collaborators together and say, hey, come to this YouTube session and we'll present our work together as if we're one organization. And this public meeting is for storage providers, and they focus on the infrastructure side of things. So how many storage providers are providing things, what kind of initiatives are going on, what are storage results, basically, of the network they discuss here. And this is the latest network stack that I got from them. It's a little bit old already. We actually have a lot better stats than these ones, and it's growing upwards. But I still wanted to use this one because it's one of the most official ones. So for the Filecoin network, on the storage side, there is 16 exabyte of network total. The latest figure is actually 18 exabytes. So since this was given in March, the storage capacity actually increased quite a bit. So 1 exabyte is about 1 million, I think 1 million terabyte. Yeah, so that's a lot of storage. To give you an example, the total amount of cloud storage in the world is 2,000 exabyte right now. That's some research that I saw today about it. So this represents almost 1% of the cloud storage. So we're we're truly a enterprise grade. So we're the network that, from a storage capacity aspect, we can kind of close enough to start to compete with cloud storage out there. We also have an increasing amount of storage providers. We used to call them miners, but because the name doesn't really suggest what they do, we've renamed them to storage providers because they are indeed providing infrastructure services. There is more than 4,000 of them since March, and it is growing in a growing speed. We have a couple of products I mentioned earlier, NFT.storage and also Web3.storage. So NFT.storage is actually a free storage for any NFT project to store their NFT on it. And it has received, usually like in 2 weeks' time, they can grow about 5 million. So in March, they had exceeded 50 million NFTs or files stored on it. That's amazing. That number is a lot bigger now because of the growth rate. And overall, on the Filecoin network, there is more than 2 million more than 2 million deals being made. So people are actually trading the storage space over there. And earlier I used the analogy of Airbnb for hard drives. And this figure shows that indeed the market has been formed. And we're not only measuring the capacity of the network, we also care about the data being used. So the utilization is also a key result that I want to see for the network. And right now there's 50, so in March, there was a 55 petabyte of network data utilized. I think this number is more than 100 petabyte now, by now. Where are they located? The storage providers continues to grow. These are the number of storage providers. And these are the distribution of where they are in the world. So China takes a big chunk of it. And then I think there's a little bit better graph than this, but this is a little bit older. Yeah, so but what we're seeing is the trend is that the Chinese storage providers are reducing. So their storage power is reducing. And it is moving to rest of the Asia. And also the North America storage is increasing as well. So the overall as a network, it is a good thing to observe because that means the storage is being more evenly distributed around the globe. So that's what we would like to see. Because this is a hackathon, I'd like to mention a few other hackathons that is going to happen later. So this one is right here, happening right now. ETHSafari by Encode. We also have East Bogota. I think that's coming in a month time. And there is a few other hackathons that we're sponsoring. We always sponsor a lot of them. If you would like to find out the rest of the hackathon activity, you can go to hackathon.filecoin.io. And if we decide to sponsor a hackathon or participate in one of the hackathons, we need to get this image fixed. It's not showing, but we'll do it after. And then you'll find the latest updates here. We'll always keep our hackathon activities here. We have an amazing hackathon operations team in the organization, and we're doing a lot of activities there. So I want to highlight this section. So if you would like to build and face some problems, or in the future, after the hackathon, you're building your own project, you can actually reach out to us by joining our Slack community, message us directly, or you can feel free to join our office hours. It's at Thursday, 2 p.m. UTC every week. One of the developer advocate will be stationed there to answer your questions. It's really fun to do that because we do it on a video platform called Gathertown, and it is like playing an RPG game. But instead, when you get close to someone, you start to video conference with that person. It's very casual and it's very easy to. It's a very casual environment for you to chat to one another. You can also schedule a formal call with one of the developer evangelists or advocates there with this link. So that Calendly link. So there you go. And if you want to be reminded of the hackathon judging criteria, there's also a link and also a bunch of material to help you to get started with IPFS and Filecoin. I'm going to just open this link to show you a little bit of what they have. So this is just like an explosion of IPFS and Filecoin sort of getting started guides here. There are information about storage helpers. If you want to go deep into IPFS, you can go that area. And if you would like to interact with the Filecoin blockchain tools, you can go here, and then a few other sort of libraries that you can use. There are also tutorials, demos, examples, videos, and AMA sessions that are a lot better than this one, recorded somewhere on this link. So feel free to check it out. And then, of course, the judging criteria, which is relevant to you all hackathon participants. So we look at projects with novelty, creativity aspect, potential impact, technical accomplishment, and also because it's a Filecoin and IPFS sponsored track, we care about the Filecoin IPFS implementation. We we have a list of requirements to any project. If you're not using the Filecoin IPFS implementation, we couldn't qualify you for the track. So pay attention to these. And on the right-hand side, I think, yeah, so on the project showcase, so over here, what qualifies as using IPFS and Filecoin technology is specified here. So we explain like whether using Morales IPFS API is eligible. Then we actually explain, yeah, we pretty much explain everything. If you have a project that uses PPP, that's also fine. That qualifies as using IPFS and Filecoin technology. We use IPFS and Filecoin as a kind of general word for the collection of technology, for the lack of a better word, describe the collection of technology that we have there. You can also just use pinning services like using Pinata, Infura, Temporal. That's also fine. Lightpeer also has integration with IPFS. If you use those things in your project, that will also work. And then one thing I want to highlight is Fleek is wonderful. It's a really good tool. It's like Netlify of Web3. It's great, but if you are only using Fleek to deploy your website, that doesn't qualify as a sort of IPFS Filecoin eligible project. However, if you use a Fleek JS library or SDK to interact with IPFS and write data to it from your application, then you're eligible. But just deploying site on Fleek or Spheron, it's not enough to justify a adequate usage of the technology. Yeah, so this page has it all. It's a very important page for you to go through if you intend to go for prizes that we want to give out. I'll talk a little bit about Web2 challenges. So we're in a movement of building Web3. And the reason is that the Web2 is not perfect. The internet that we're using right now is not perfect. We're seeing we're seeing these days are the rise of the platform businesses. So all of these logos that we interact with every day, they're platform businesses that are centralized services to provide content. But where did the content come from? Where did the usage come from? It actually came from every one of us. So they have made internet extremely easy to use. So you can download an app or visit a website, log in, register as a user, and start to write things and create things on them. But they're actually using the centralized model to host everything. So that causes one problem. If some of them goes down, your content is not available. If let's say AWS, their data center goes down, or a CDN that goes down, because the centralized design, a lot of things could be unavailable to you. And it also creates a lot of silos. The reason why it is it's intrinsically using a location-based addressing schema to visiting the website. So when you're typing a URL domain name, it translates to IP addresses. We all know that. And it tries to find a file located in that server. Much like our computer uses pass to find the file, and the internet works similarly. But this was a design decision that people have made a long time ago because it's most intuitive and easiest to implement. So it was done this way. So it means that there's actually a lot of contents available and being duplicated all around the internet, but you can't access it because the kind of portal or the platform that you use to access it is down, and then you're being locked away from that content forever. So what we are trying to do, so imagine like the content is actually being downloaded and it's sitting in your housemate's computer, but you can never access it because they're using a different platform, or you just can't access it. Then that's a shame, because those resources are actually available locally near your area. If you're cut off from maybe the external internet or from a certain platform, you should be able to actually get the other files. On top of not making things available and centralization failure, the other thing is the internet is incredibly inefficient right now, because same content actually gets downloaded multiple times to different people. Let's imagine a YouTube video being watched. it is actually being downloaded from your nearest CDN over and over again to different computers. But if we have a peer-to-peer system where each peers can share files with each other, then we're actually using the internet in a smarter way, because each one of them will actually share it, and you get the content from the closest station instead of always going to a centralized server to download it, leaving lots of bandwidth being consumed for the same content. So the current internet has a few problems. If something gets disconnected, like a server or a central hub, then you're cut off from all the services or the content that you wanted. It is not bandwidth efficient. It is not made for offline. A lot of applications don't work offline, and permanence is a problem. Like there's a research done that the normal website, the average website lifespan is 2.5 years or 2.7 years, and that's incredibly short, because there's compared to the information. Like if you write a book, then the book can last quite a long time, but the content on the internet doesn't last for more than 2.5 years on average. So a lot of pages that you're seeing right now, it could be gone in 2 years' time or sooner. It's so easy to be controlled because the centralized nature of it. The government just need to control a few central points to be able to control the internet. Yeah, so these are all the problems with current internet and the Web3. So, and IPFS, what it intends to build is a file system that is offline first, that is smarter, so no duplication of data and saving bandwidth. It is fully distributed, meaning that you can't ban it. No single authority can ban it. It should support permanence. It should help with permanence, and it should be safer, so secure to use, and faster. And faster in theory should be faster than the centralized model. So the IPFS actually changes the location-based addressing for the internet. We intend to build a new internet, so IPFS would like to change it to a content-based addressing. So instead of asking where the content is, where the website is, we're asking like, I need this website, this specific contents directly, and the system should retrieve the content no matter where it is. So if it is near you, then that's great. So get it from your housemate's computer. If it is far, then we need to go through a few hoops to actually get the content and serve it. So that's the intention of IPFS. So changing from location-based addressing to content-based addressing. IPFS gets used by a lot of applications. These are just a few. This is not exhaustive list of ecosystem of application that uses IPFS. A lot of people in NFT space also knows about IPFS, and everyone knows about writing IPFS URL or CIDs into the NFT metadata and the contract, so it can be immutably stored. The reference is not easily changed. IPFS is integrated in browser. If you download Brave or Opera and type in IPFS : / and a CID, you'll be able to visit it. The hope is that in the future, all web browsers should be able to talk to IPFS natively and treat it as the same as HTTP. But this is still a work in progress with major browsers like Chrome and Firefox, and there are people working on this in Protocol Labs right now. There's also standard being done based on IPFS or related technology for decentralized IDs. You can check out this project called Ceramic, and they have a integration with IPFS as well, and they're trying to start their own standard for DIDs. That could have a huge implication on how we build DApp in the future. There is a lot of, it is an open source project, so there is a lot of contributors in IPFS every month. So if you think certain parts can be improved, if you would like to dedicate some time to fix certain things in the tooling on IPFS, feel free to do so and contribute. That could also be your hackathon project. So I think I won't say more about Web3. I think that's enough me talking. I don't want to bore everyone. Does anyone have questions for me? Yeah, sure. What is the difference between Filecoin and Arweave? So Filecoin, so I can use this to explain. I actually didn't look into Arweave too deeply, so I don't exactly understand its mechanisms. But I can talk about Filecoins in quite a bit of details. So you can see this graph. So Filecoin works by clients making storage deals with storage providers, which are miners, in another word. So when the storage is offered, it goes onto a marketplace, open marketplace, and then the storage provider actually compete to offer the storage to the client. So it is a dynamic marketplace. And then when they make the deal actually expires in 6 to 18 months time. So it's by design. So it's time bounded deals, and then it expires. So you need to renegotiate the deal to keep going. So this provides a mechanism for market to adjust itself based on current situation. It keeps it's a sustainable ecosystem. So this is probably a little bit more complicated than the offering out there, but we're trying to make tools that allows developers to not worry about all these deal making and abstract it. I'll talk about that in a little bit. But this is essentially how Filecoin deals works. And then for Arweave, my understanding is it's the idea of permaweb. So you pay once, and then a miner or a storage provider will store your file forever. So it's a simpler proposition than Filecoin, the way I think this is. So both Arweave and Filecoin are based on IPFS. So IPFS is the technology that both uses, and that's the same. That doesn't change. So I hope it explains the difference between Filecoin and Arweave. There is actually a really good article on Masari that did a comparison between Filecoin and Arweave. If someone search for that, you'll be able to find that. How does there's another question. One-ish asks, how does Filecoin token tie into the model? So Filecoin is being used for making storage deals, simply put. So it is a utility coin made for the storage market that we're trying to grow. So right now the usage of the coin is basically for the storage. But we're working on something really exciting. That's Filecoin virtual machine. Now Filecoin virtual machine will from AWS use my own PA on AWS. So that's the next question, but I'll go through this first. So Filecoin virtual machine is actually a virtual machine built on top of Filecoin's protocol. So it will allow the developers to customize the actor on the nodes to be able to execute their smart contract. So this will allow Filecoin to be used in the non-storage related purposes. So this will bring more type of utility to the Filecoin token itself. So hopefully, like layer 2 and all these DeFi projects, maybe NFT, and all these are possible with the help of Filecoin virtual machine. And if we invite the L2 solutions to build on top of Filecoin, then that will be able to provide even more performance for certain industries and utilization. So SPQR asked for a different question. Can I use virtual machines from AWS instead of my own PC? So I'm not sure what the virtual machine is, what you're referring to. I think it's the node implementation. So let me bring out one slide for you that I made earlier. Yes, so it is possible to have your node running on AWS instead of your own PC. And the primary node implementation actually is Lotus. So Lotus actually has Amazon machine images available for you to load. You can fire it up within like a couple of clicks and start to interact with Filecoin blockchain from AWS. So that's totally possible. And the good news is Infura, so by consensus, they actually have solutions to have a hosted solution for that. So if we let's go to Infura and take a look. So Infura.io, if we want to products, IPFS, so there's IPFS API. So over here, you can actually spin up, like instead of an Ethereum node, you can spin up a Filecoin node and have your private Filecoin node running on the Infura network. I don't know what they use under the bonnet, but this is a way to actually have a hosted solution rather than running on your laptop, which could be resource intensive. And if you want a full node, you might need to wait for a very long time to be able to be in sync with the blockchain. This is a talk I've written for developing on Filecoin Lotus, which is the most popular implementation for Filecoin network. So just to give you an idea, there are 3 implementations for Filecoin. Each has different capabilities. Lotus and Venus are quite similar. And then Forest is maintained by ChainSafe. So with Lotus, you can, it doesn't matter where you run it. It's based on Go and Rust, 2 languages. You can install it on your local machine to run it. I actually have one running on testnet on my machine, or you can have it hosted online. So this is a feature comparison between all of the implementation. Lotus has most of the features, and Venus has most of the features as well, but some of the build, it refers to the Lotus implementation. And Forest is only a node, so it participates in the blockchain network, and rest of the functions are still in progress. Yeah, so it has a CLI access, so you can interact with it with CLI. You can also use their API to interact with it. We also have libraries. So after you have spin up your Lotus node, you can connect to its HTTP JSON RPC endpoint and use some libraries to interact with it. So can we use this already? I don't know. Helios, can you clarify on what this means? FEM is programmable, should be programmable soon. So from September, October, they're planning a launch right now. So in October they can launch, and then you can look into the documentation of it. I actually haven't been following that project myself, but it will be an exciting launch very soon. So stay tuned. Yeah, but unfortunately, I don't think you can use it in this project because it's not programmable yet. The question by Scoop SC00B, is NFT storage built by Filecoin? Yes, so NFT storage is, I should say, closely affiliated with us and sponsored by us. It's made by Protocol Labs, which is the research and engineering company that created IPFS, and they also helped the launch of Filecoin. So Filecoin Foundation is an independent organization, but we have really a lot of things to do with Protocol Labs and good friends with Protocol Labs. So it is made by Protocol Labs. You can say it's made by Filecoin as well because of our affiliation. Yeah, so yeah. So NFT storage is quite interesting. I really like how simple it is. So you can log in with your GitHub account, and you can almost use it as like a Dropbox for NFT. There is actually a software. If you need to upload, this is the thing, like a lot of people like to do a lot of NFTs at once, like 10,000 images at once. You can actually download a desktop software called NFT app, and drag and drop your files there with metadata. like a JSON file related to it, and upload the metadata at the same time to IPFS. So your metadata is there, but also the asset is there as well. So these are like the files that I have done probably for testing before. And if I would like to, so these are actually this Filecoin storage provider that is storing my file that's being uploaded. Well, there's a lot more for this file. It's really redundant then for this one. I don't know why. So if I would like to visit this file, actually, let me not do this file. I don't know what it is. So it might be something rude and I can't show on this streaming. But if you look at here, the NFT app, let me see if I can find it. I can't find it. Yeah, upload with NFT app. So this is the, like, I think it only works for Mac for now. Yeah, so if you drag and drop, you can upload files in batch. And it's quite cool to upload that many files at once. So yeah, so I got a few questions now. Thank you for asking questions. It is an AMA, so by participating, you're making this real. How is this different than Filecoin? I think it offers the same thing. Maybe Shimo H, can you elaborate a little bit more? What is different than Filecoin? So I'll go on to answer the next question. Is NFT storage free? So NFT storage is free and should stay free for a very long time. So where does it explain the cost? So basically what we see is like Filecoin Foundation, our mission is to is the steward of the Filecoin community, right? And also we aspire to put the power of humanity's most important information back to the hands of everyone. And Filecoin network is intended to store humanity's most important information. So what Filecoin decided to do a while ago, and together with Protocol Labs, is to form a working group and a program called Filecoin Plus. So over here. So Filecoin Plus is a program that they look at different kind of storage data that's being stored around the world, and the need for storage. What they do is they decide on what files are actually valuable to humanity, and then they will make sure that these files are tagged as verifiable data. So verified data are done by a group of notaries. It's a notary system. So those notaries, there's more than 100 of them now. They will give out data caps, which are essentially free storage for clients to use. So these clients can be SOA Foundation, could be like Internet Archive. So these people over here, they could be our clients. But also NFT storage is one of the clients for Filecoin Plus program. So they're receiving funds from Filecoin Plus program so that they can stay free, because we see NFT as one of the most important humanity data to be stored. So therefore it is free. So it should stay free for a very long time, as long as Filecoin Plus program is sponsoring it still. All right, so free for 30 gigabyte. Okay, current limit is 31 gigabyte per individual upload. I don't think there's a limit on, but I can look into this and confirm this. The next question: are there other projects like NFT storage that's done by you guys? Yes. Carnage. There's another project called Web3.storage, and I just learned from the Filecoin Green project that CO2.storage is a thing. So CO2 storage is okay, that's not the one, but there is a CO2.storage from the latest ecosystem update. Let me see. .storage. Okay, here we go. So it's a free decentralized storage for environmental assets on IPFS and Filecoin. So CO2.storage will help you to figure out what you actually bought. So they're related to sustainability and making blockchain green. So that's what the Filecoin Green team is trying to do. And then for anything that's not NFT, we have a Web3 storage as a service to developers, mainly developers, because it's a developer-focused tool. So the way it works is it's very similar to NFT.storage. So it provides API interface for developers to upload files to IPFS and Filecoin. And then it has SDKs for people to embed into their application. The pricing, so the interface works a little bit differently, but it's pretty much similar features as NFT.storage. So it is free for first terabyte, but right now you need to request. So if you need to tell us the reason for using more than 1 terabyte, it is still free for now, but the team is working on a pricing strategy. So we don't know the pricing yet, but when it's released, we'll know that exactly how much Web3.storage costs beyond 1 terabyte. So that's another project, good project by us. Also, there is S3.tech. So that's also built by us. So S3.tech is actually, so there is a cloud version of it, like hosted version of it, but it's actually made for developers to download, install on their own server and start their own kind of S3 node. So you can interact with IPFS and Filecoin easily, and those like deal making becomes one single API call, etc. Those things will be quite easy. For S3.cloud, I think this login will still work. So yeah, so over here, S3 cloud version, you need to request for API. It's a bit manual because it's not intended to be a cloud storage or centralized service for everyone to use. So over here, I can like easily upload a really easy file. And then, so over here, upload all, and then it will pin it on the S3 node that's being hosted by Protocol Labs, and it will pin it on IPFS. So I can, so actually I can see my pinned file from the portal gateway, IPFS gateway. A little bit slow always for new files. And then behind the hood, so behind the scenes, it actually goes out and make a storage deal with storage providers, although this file is way too small, so I don't think anyone is going to take this deal. So that's an easy way to actually interact with Filecoin rather than go on to establish your own node, have Lotus running, and then use Lotus CLI to make a deal, or API to make a deal with a storage provider. So that's another project. So in short, NFT.storage, Web3.storage, and S3.tech. And if your project is environmentally related, soon, I think in the future, you can use CO2.storage. I have another question from Jonathan. What is the difference between NFT storage and Web3 storage? Also, I find Web3 storage more easy to use than NFT storage. I agree, Web3 storage is the one that I did my demo application on. I really like the experience. I don't actually know the NFT storage challenge in its usage. I haven't written a lot of programs that talks to NFT.storage yet. NFT.storage and Web3.storage are both services, like I call them storage like a gateway softwares, or it should be called storage helpers. So what they do is they help you to put files, pin files on IPFS, and then behind the scenes make deals on Filecoin so it persists. But once it's off, like once it's uploaded on IPFS and it kind of your file is kind of is stored on DWeb and on the IPFS network itself. So it helps you to get there fast. So those are things. So as from a function, like for the application, they're about the same thing, but technically there must be differences between them. But I haven't looked into exactly what the differences are. So from a business use case perspective, NFT should be used for NFT and NFT only, and then it's designed for NFTs. And then the Web3 storage should be used for generalized application storage. It's worth to mention that NFT storage to make retrieving really fast, because a lot of people need to see their NFTs, need to display their NFTs everywhere. NFT.storage also made a something called a super hot. So it is a very fast retrieval gateway for IPFS. So if you upload it through NFT.storage, you can use NFT-storage.link, this IPFS gateway, to retrieve it, and it should be very performant for your project. So I have a think of using this for your own project, and you can read more about it. So I will show you a little bit of code that I have already written. I'm not going to write live code. I'm not good at writing code on the AMA or on the live streaming. But here's one I prepared earlier. This is an application that I wrote for a Chinese education series, but it's in English, so anyone can go to this link and take a look and copy it. So it's called IPFS Filecoin dApp demo. And actually, before I made this, I made another simple application called IPFS storage demo. So they're actually a very simple program. They just allow you to upload a file to web3.storage. And yes, both of them are using web3.storage because it's easy. And I keep going back to it. The other software, one of the software only uploads to web3.storage. And then the other one, the dApp one, actually has a Solidity contract on it. So before you upload it, you will upload a file. You will need to pay a certain amount of money in Ethereum to be able to upload it. And then for the non-Ethereum and for downloading it, you also need to pay certain Ethereum to be able to download it. It's like a very simple business logic behind it to demonstrate the ability of using Web3 storage together with the smart contract. I'm not sure what happened to GitHub now. Oh yeah, it seems like my personal dashboard is loading very slowly. But you can see here. So this is the dApp version of it. I made a little GIF here. So you click on upload file, select the file, and then it will prompt for MetaMask confirmation for transferring 1 ETH. That's the expensive file to upload. But don't worry, when your friend wants to download it, they will also need to pay like 1 ETH, and then you'll get a share back. The software is gating the IPFS CID before the downloader is able to download. There's no CID display, so that's all it does. So we'll display the CID of it. The smart contract will actually store the file in the smart contract in an array, or I should say a mapping, and then each file will have a ID on it. So when the smart contract gets executed, when the download file contract gets executed, it will look up the file ID, retrieve the CID, and serve it. So when the uploader is uploading the file, they will actually store the CID right in the smart contract. So it's retrieved through the smart contract becomes the database for different files that's being uploaded. And the only way to retrieve that CID that uploader knows is to pay the money to get it on, pay the money to be as a downloader, pay the money, and then get it out. So that's how it works. For the non-smart contract version, so storage API in general. So for the other one, it's just simply a interface to select a few files and then upload to web3.storage. And after uploading it, it will create a single CID link for you to visit, and you can use dweb.link gateway to download those files. So on the right-hand side, what you're seeing is what this IPFS demo application does. So it is a simple React application with different modules in there. It's just one page, and then it shows and hides the different components by using very simple logics on the front end. So if the CID is there, and then it shows a file uploader. If CID is not there, and then show the uploader component. And if it is not, then that means someone has already successfully uploaded. So we show the success page. And if the sending is being flagged, then we're in the sending status. So you show the spinning stuff. And if you have arrow, show the IPFS arrow page. So the meat of the project is actually here. You can see that I've included Web3 storage API, the SDK here to interact with Web3 storage API, like so. And then on the submission of the web form that selects the files, I spin up a client. So I instantiated a client with the token that I stored in my environment variable. So over here, and then that token is retrieved. So now I can talk to my account on Web3 storage via API. And then I will use this client.putFiles method to put the file in there. What it creates is a root CID for me to visit. So hopefully it will still run. Let me see. It's been a while since I write this. Let's retransfer and start. Should still run. So yeah, here we go. So if I select some files, I probably have done this a million times, these two files, and then can show you behind the scenes. I will send. There's some complaint on my syntax. So some of my front-end code is not written very well. So there you go. So the two image files that I have uploaded should now be in my web3.storage account. So if I go to my account and let it retrieve all of the files that is under my account, it's yeah. So over here, this should be the file that I have uploaded. So let's see, the CID is, let me make this bigger. CID is K7DM, and then over here, K7DM. So this is actually the same file. And if I click on this link, it should take me to DWeb gateway, IPFS gateway, which I find like perform a bit better than IPFS.io gateway sometimes. Hopefully this time as well. And it looks like it's not. Okay, that's fine. That's fine. So so this completes the kind of the cycle. So everything is uploaded to Web3 storage. Web3 helps us to push to IPFS, create the CID, and then it now pings the file to the to IPFS on Web3 storage server. And now what it does is by using the dweb.link, we're trying to retrieve it through a gateway, and the gateway talks to IPFS, and it makes requests in the peer-to-peer network and try to find that content from Web3 storage. So that's what it's doing behind the scene. So while it's spinning, trying to find it. Uh-oh, we got a gateway timeout. So I'll just try a little bit more. I find I find that you have to wait for a few minutes after uploading for this to work well. So meanwhile, I'd like to show you like the software that I have written here, which is considered a front-end only application. So over here, front-end only application. You can test locally, but for your actual project, you can deploy through Flick quite easily. So in my README documentation, you can see that I included one section about Flick. The Flick is extremely easy to use. This is my Flick account. I can log in with my GitHub account. as well. I think I'm already logged in. So you can see that these are actually the websites that I have hosted here. And it connects to my GitHub repository very easily. So through some GitHub authentication, I was able to find this repo and say, hey, here's my repo, here's my code. Please retrieve it and also build it for me and run it and put it on IPFS for me. So it does exactly that. And it gives you a Web2 domain address for you to visit. So the application that I've written, Filecoin storage demo, it is now live over here. So, and it is linked to my web3.storage account. So there you go. So I encourage you to actually use this fleet for your project. So let's give this another try. What if I upload another one? Closed. So this has been uploaded before to Web3 storage, and the gateway is able to find it. I hope this returns a better result. No, we seem to have some problem here. So if you are unsure about which gateway to use, you can go to IPFS gateway and you can find a whole list of IPFS gateway there. Do some tests or refer to this table. It will give you the kind of the latency test and the performance of this gateway. It's actually doing a test right here, and you can pick one to use. So gateway.ipfs.io, CF IPFS, etc. There. I'm not sure what's wrong here, and here seems like the dweb.link IPFS gateway is not performing well right now. So what I'll do is I'll give this demo link to you all as well. Feel free to copy from it if you like. So the file uploader, the important part is here. And for the dweb one, so the one with MetaMask integration, it is a Vue application. So I try to use a different front-end framework to run it. And then there's the contract here for everyone to look at. Please, this contract is not perfect. Please let me know what I can improve on this and how I can make this more secure if you're a DApp specialist. And then for the actual data storage, it is in the components file uploader. So over here, so here are some of the stuff that I use to deal with MetaMask and the Ethereum development environment, but the actual the part that is in charge of uploading the file is here, and there's a downloading section as well. So I will put this here, and to go to the downloader section. So for downloading, I'm actually using Ethereum ethers.js to interact with. I'll make this a little bit bigger. So I'm using ether.js to interact with the contract, and then nominate a figure to pay. And upon successful payment, I'll trigger the download file contract. And that will return the CID, and then I'll use the CID to actually retrieve the file. Sorry about that. So I'll copy this and put it in the chat as well for you. Yeah, it's really a pleasure. as you can tell, I don't know everything. There's a few things that I couldn't answer, which is great because I now know where I can learn on my job. And I hope you have learned something as well from this session, so you can better understand and use the IPFS and Filecoin technology. Lastly, I want to show you this. I just finally got the vendor image working. So from my application over here, upload a vendor, send to there. I think it's already like made the root and it's all working. So the gateway is able to retrieve it. Just it took a long while though. It took a long while. So the IPFS technology works quite differently than the client-server model. Client-server model, you can always expect a certain performance, but depending on where files are located and how many nodes that it needs to retrieve, IPFS will offer varying performance. So if the file is on the local Wi-Fi network, same as your like in your home, then it's ultra fast. But if the file is actually quite far away from you and needs to go through like 200 computers to get to you, then the performance is a lot worse because it's doing something different than just talking to one server. So there you go. If it's on IPFS node, it loads faster. Yes, it is. It will load faster because you're basically uploading to your local machine and then retrieving from your local machine because it knows that on your hard drive, you actually have that content. So it'll be a lot faster. Yeah. Also, if you host a IPFS node on Ethereum, or you can do it on AWS as well. So if you host your own IPFS node, then you know that it's always there. And probably the distance of you and that node, then it will offer a consistent performance.
Awesome. Thank you so much, Jenks. And thank you everyone for coming. I hope the majority of your questions were answered. And if any other questions pop up, just pop it in the technical question section on the Discord. And yeah, thank you so much for coming, Jenks. Thank you for taking time out of your day to answer these questions. We really do appreciate it. Good luck to everyone for the last week of the hackathon. Keep hacking. We're almost there. I'm sure we're going to see some awesome projects. I've spoken to a lot of you and there's a lot of cool projects coming up. Lots to do with Filecoin and IPFS. So Jenks is your man if you've got any questions. Hope you have a lovely rest of your day. Awesome. Bye, everyone.